All right, welcome everyone to the February 24th Arborist call. Standard agenda, just kind of a quick intro. We have status updates from the ZebraD and Zcashd teams. Then we kind of go into a period of open discussion. Primary focus for the last several months has been in U5, so we'll talk about that today, a little bit of status, timeline updates. And then we have QEDIT with us this morning. This morning for me, evening for them. But they'll be providing, kind of a discussion around the ZSA work they're doing associated with their grant that they have. And then we just have a wrap up. I'd encourage anyone throughout the call to ask any questions, drop it in chat. People are pretty responsive there. So we'll just carry on. Arborist calls are all about protocol development. So anything and everything R&D, design, implementation, new features, blockers, etc. And it's for, basically to make protocol development more accessible. So we get everybody together that's doing anything with protocol or interested in protocol every couple of weeks to provide updates and discuss open issues, etc. Anyone can participate. Obviously, you can watch the playback on our YouTube channel. You can register, hang out in the meeting, ask questions, listen. If there's something you want to present or you'd like discussed at a future Arborist call, you can just contact me, Stephen at electriccoin.co, and we'll get that scheduled. Yeah, so pretty much it. So we kind of move into the status updates. Let's see, Conrado, are you going to do one today for Zebra?
Yep.
Okay,
Yep.
all right. Do you want to share your screen?
No, there's a need.
Okay, all right, we'll leave it right there then.
Thank you. Hi, everyone. Basically, these last 2 weeks, we completed, we've been going over each consensus rule from the spec, double checking if it actually implemented and documenting in the source code where it's implemented. So we basically completed this work. We missed only a single rule, which was we weren't validating the sapling anchors, the specific range. It must be smaller than a prime. We were accepting any byte buffer with the right length. So we added that, and to the best of our knowledge, we are validating everything. We also added a check with Strad, realized it was missing in the spec. It's being added, but basically we need to check the Coinbase script. There's a range, a minimum and maximum length. We are now validating this. Something very exciting is we have a full sync test. Beforehand, every time there was a merge to main, we would CI would automatically deploy a node, but that's it. If it panicked, we would get a notification, but other than that, we wouldn't get notified if it finally synced, how long it would take. So Gustavo worked hard on that, and now we have a specific test that syncs the node to the tip and notifies you with how long did it take and if it worked or not. So this is something that is very, very useful, especially to catch. For example, we do some change in the source code that makes sync take twice the time. Before that, we wouldn't realize that right away, and now we will. We now allow more inbound and outbound connections. This is something that we discussed, I think, in the last Arborist call about how this should work. Then realize that we should have a larger inbound limit than outbound. So we changed that too. It's a bigger limit than Zcashd uses, but it's the other way around.
What did you, if I could just ask, what kind of what was the limit that you all decided on for inbound and outbound?
Good question. I think it's, sorry, I don't remember it. Maybe 75. I think the outbound limit was 75.
Okay.
So I think the inbound now is 75. The outbound is something smaller than that. I think it's something like that.
And ours is 8, right, on
It's
Zcashd?
8. Yeah, it's
Yeah.
8. Yeah.
And I remember the last Arborist call, we had some discussion about that. Is there any concerns over that many outbound connections, or is that not, it doesn't really matter? I'm primarily asking Darren Strad.
The concern was the asymmetry, basically, like if it was
Okay.
opening more outbounds than it was accepting inbounds.
Okay.
Yeah, I think
So
we discussed it and we came to yes, the inbound must be larger than outbound, but the specific value, it was 8 because at that time when Bitcoin was, when we were forking from Bitcoin,
Mm-hmm.
the network speeds were slower, and so that seemed a good limit at the time, but it seems that a larger limit now it's fine.
Mm-hmm. Okay.
So I just found the PR. It says I kept the outbound connection limit the same as 75 and increased the inbound from 50 to 125. So
Right.
this
Thank
makes
you.
Zebra's inbound connection limit close to Zcashd's, which I believe is 128.
Thank you. Yeah.
Mm-hmm. Okay. All right. And that's Zebra pool 3527. So PR
Yeah.
3527.
Yeah.
Okay.
Thank you.
Mhm.
And other than that, I mean, all this work is focused on getting a stable release candidate
Mhm.
version of Zebra. I think we're almost done with that. We just now need to, update everything related to NU5 dependencies.
Right.
So when those are released, we have a little bit more work just upgrading those dependencies and adapting the code where it's necessary,
Mhm.
and then we'll cut the release candidate. Sorry, this table release candidate release, which we will then send for an audit.
Okay. All right. So that was the one question I had this morning was that'll be the release that you kind of pass along for the
Yeah,
kind of the implementation audit. Arguably, like the
exactly.
spec audit was done by QEDIT NCC earlier. So this will be implementation of the spec in Zebra D.
Yeah,
Okay.
yeah. I think the goal for the audit is maybe to do both. Validate if we're actually implementing all the consensus rules correctly.
Right.
But
yeah, you definitely have to refer back to the spec to know if it's done correct. So
yeah,
you're kind of
exactly.
doing a little bit of both anyway.
Yeah,
Yeah. So okay. All right. Sounds good. Yeah.
yeah.
Okay.
And since we almost finished with that, we start working on the next step, the next epic for the Zebra project,
Mhm.
which is basically we want Zebra to be able to work as a backend for Light Wallet D.
Okay.
So basically, to do that, we need to implement a set of RPC calls in the same way that Zcashd does, right?
Yeah.
So we already mapped everything that we need to do.
Okay.
We're going to discuss with Aditya later this day, just to ask some questions and to clarify some things.
Mhm.
But yeah, we already started this work. We started we create RPC port so that the light wallet D can connect.
Mhm.
We already found some discrepancies, like light wallet D, when we make the RPC connection, it will send there's a field that indicates the version of the JSON RPC protocol.
Mhm.
But I think the protocol states that you should send a version if it's 2.0, but you should not send anything if it's 1.0. But I think Light Wallet D is actually sending 1.0. So since the library that we're using didn't support that, we had to do a small hack to remove this value before going to the library.
Mhm.
But yeah, those kind of conflicts arise, and you just have to deal with them.
Okay.
But yeah, I think it's going well. We did some small changes to the database, and we also need a new function in Zcash script, which is basically to get an address from an output. So I'm currently working on this. It should be complicated.
Okay.
And that's it.
Okay, cool. Go ahead. I thought someone was about to speak. Nope. Okay. I was going to say on the light wallet D work that y'all are doing, Larry on our side, on our team, is pretty familiar with that code too. So you could just, if you had any questions anywhere, just tag him in Discord or something.
Sure.
He kind of works with it quite a bit on our side. So glad to help or
Great.
answer.
Yeah, actually,
Thank
I was going to ask if it's okay if we maybe pull him in for a quick meeting, just explain what it is that we're planning to do, so that he can
Sure. Mhm.
give us a bit of a kind of a sanity check.
Yeah, absolutely. Yeah, I think he's heads down on a couple things this morning. He was just on stand up with us earlier, but sure, just tag him in Discord, connect with him, be happy to hop on a call. Super knowledgeable about that.
Yeah.
My wallet D. So yep.
Yeah, and just provide some context. Our intent there is to basically get Zebra capable of acting as the back end,
Right.
and then in due course, look to become more actively involved in the light wallet working group and whatnot. But first things first.
Right. Yeah. Absolutely. Yeah. Cool. Okay. Sounds good. Yeah, I noticed Tiara was had a couple questions about RPCs. I guess a couple weeks ago about, are you going to add this one? Are you going to add that one? We're like, yes, and we forgot that one. Let's add it really quickly. So we had to update. I think it was Zget tree state to include the orchard info as well, but we got that done pretty quick. So cool. All right. Anything else, Conrado?
No, that's it. Thank you.
Okay. All right. Appreciate the update. Good one. All right. Moving ahead. Zcashd. We really kind of roll our node update into the NU5 discussion because that's essentially all we're focused on at the moment. So just kind of bounce ahead to NU5. These are for reference for anyone that happens to just pick a random Arborist call to watch and hasn't watched the entire series, if you will. So these are the new NU5 zips that'll be going in when it activates. These are modified zips to account for, orchard information, for example. So that's the list. In terms of Zcashd release timeline, this is kind of the overall timeline over the past several network upgrades. We're obviously in here. Next up for us is 470, which is our exclusive focus at the moment. We'll talk more about that in a moment in terms of content, what we're getting in there. Short version is it'll be basically everything needed for mainnet activation except mainnet height. Now there obviously will be some additional things we put in. The key point there is for 470, when that goes out, then we'll have everything that our partners need to, they've been testing kind of compatibility with, sapling, et cetera, but this will be able to exercise some of the new RPCs, orchard pool, unified addresses, et cetera, on testnet. So we'll get that out. We'll do a testnet reactivation, about a week later, roughly. It's probably what it'll work out being. And then we'll, of course, all of our 4.* releases EOS halt before NU5 activation. We'll have a couple of, 5.0.0 will set the mainnet activation height. And then we'll put out 5.10 just so we have 2 releases in the field when NU5 activates. Gating factors for us for NU5 or for 5.0.0, I should say, are one is we have in progress another kind of internal review of the circuit code, the consensus logic. We're working on that. And then we've kind of got an internal, all thumbs up kind of thing, which is going really well. We don't expect to find anything, but we do want to make another complete pass through everything. And then also the security proof that Sean's working on with Dara Strad, Mary Mahler, and others. Sean, I don't know if you want to provide just a brief update on that. I know that that's in progress.
Yeah, Mary got back with us with some notes on some changes and improvements. So we're just we'll we'll address those and then send them back to Mary to look over it again. So.
Cool. All right. Very good, but that's going really well. Proof is hard for me to understand, but the proof is getting much cleaner and simpler. So great progress there. So that's this is kind of the holistic NU5 timeline from kind of beginning to end. We're kind of in this partner adoption phase right now. And then this is just the testnet reactivation, 5.0.0 and NU5 activation in a kind of a different view. So any questions about that before I move on? No? Okay, all right, I'm gonna bounce up one. Oh, I went too many slides. Okay, so I'm gonna actually stop sharing my screen here. I know Daniel's on the call and he's actually trying to juggle a couple of calls at the moment. So actually we lost Daniel somewhere, I think. Maybe he rejoined. Nope. Oh, there he is. Okay, sorry. I was actually looking for Daniel and I just see now his kind of placeholder image there. So I know he had let me know that he's had a couple of calls he was trying to juggle at the same time. So we'll give him just a moment. But any questions from anyone about anything we've kind of went over so far? Zcashd, great progress on that, by the way. Great update, and then kind of where we're at on the NU5 side. So. Nope. Oh, Nate, go ahead.
I can always think of questions.
Hands are welcome. So just raise your hand or just start talking, whatever you want to do.
So it sounds like the questions around like the inbound and outbound limitations for the different clients are partially like a tuning thing about network topology. Should we try to organize some sort of like testnet experimentation where we run a bunch of nodes from both implementations and observe what the topology looks like, or would that be helpful, or given the amount of effort it would take to set up, or is it just something we can observe on the main testnet?
Well, we've not finalized the numbers yet, we've set the numbers that Conrado described for the time being, but we've not finalized them because we wanted to get the full test suite going so that we could see if there's any potentially see if there's any performance implications. We're also planning, so as well as getting an audit done, we're planning to go back to EQ Labs and talk to them a little bit about kind of retesting Zebra against Ziggurat, and we'll also ask them for just like a general view of things, and we'll mention this thing specifically to ask for their input on it.
Good idea.
And yeah, depending on who we get for the audit, they may be able to also have some input in that. So yeah, I wouldn't assume that what we've got set at the moment is going to be our final number. And yeah, we'll obviously be looking more at it, but we just set it to those numbers for the time being.
Okay. All right. Let's see, Addy.
So Nate, I like the idea of doing a testnet version of this first, especially since we're planning to go from 8 connections to 150 plus, knowing that we only have around 300 open discoverable nodes. Maybe we should consider some kind of a phased upgrade, like not go all in at once.
What do you?
I wonder how that could work, because like users, it's open source, right? Anyone can run it and join the network. So how could we do that? Do you have ideas?
Right, maybe like not directly hardcoding the large number of connections at once, but over the subsequent versions of upgrades. So we'll learn of how the interactions take place within the existing 300 open nodes. Because at 300, it's almost like every node is connecting with every other node.
Yeah, I mean, as I said, these numbers aren't finalized.
Yeah,
we're gonna look more at it. We're gonna talk to some people, and then we'll decide what we're gonna do.
Yeah. It's kind
I
of,
don't want to decide now because
Yeah,
we
for
need
sure.
we
Yeah.
want more information. I think it'd be very premature. So I appreciate that the people are maybe concerned about this, but
Yeah.
we want to look at it. We want to assess it further before we decide what we're going to do. We're not going to decide that now.
oh, of course, yeah.
And I am conceptually very happy with improving connectivity of the overall network.
Yeah. Mhm.
So if we are confident that we can raise those limits in Zebra's case, then that'll be good.
Mhm. Cool. Yep, sounds good. All right. Any other questions from anyone so far?
Well, I still have more
Oh, go ahead. Sure.
questions about the network. If so, what kind of goals do we want for the network? It feels like we want to ensure that the network is resilient and supports permissionless entry. And then we also want network privacy, but I feel like the right way to get network privacy isn't by fiddling with our P2P protocol, but using something else like Tor or a mixnet. So if we assume the privacy piece is sort of, or could be taken care of by some other component, then for the remainder, do we want just a fully connected network of full nodes? What are the trade-offs there between denial of service resistance and connectivity,
so I mean,
censorship resistance?
How do you enforce that a network is fully connected?
Right.
Because each node only has the nodes that it's able to see. So
we don't enforce it, but if there are 300 nodes and every Zebra node connects to say more than 300, or every node, we could change Zcashd also.
Oh, okay. Yeah.
If we change that parameter to be larger than what currently exists, then maybe it would become fully connected for now, unless more nodes join.
I mean, I think this is just that as far as I know, the only reason for the connection limits was resource exhaustion on sockets and
right, file descriptors,
file handles and network bandwidth and things like that.
Deirdre.
Memory.
Oh, yeah, memory. Yeah.
One of when we started building Zebra on top of these Tokyo async runtime primitives, we knew that we could, in theory, get a highly connected and highly resilient full node connecting to the network. And we basically were able to prove that early on. But we did not want to overwhelm the other nodes on the network that did not support that hard-coded at the time. So we pulled it back. In terms of balancing the nice benefits of highly connected nodes are able to get as good a view of the chain that everyone else is seeing as possible, as quickly as possible, and to get transactions into their mempool very quickly. And then to spread it around as much as after they're validated as quickly as possible. It's nice for syncing quickly. It's nice for getting up to speed with mempool quickly. It's nice for those reasons. On the other hand, if you send a raw transaction and it goes into the mempool and it goes to literally every node on the network immediately because you're highly connected, every node on the network knows your IP address where that transaction entered the network. Probably Tor, which Zebra is trying to build in as a flag, basically, so that you would transmit your transaction on the network from your Tor exit node, not from your real IP address, which is that's the goal. The secondary thing we could do is one of these Dandelion ++ broadcast protocols, which is that the peer-to-peer network understands that you do one hop, or however many hops, and then broadcast to the entire network to bring the bar up for an adversary that's doing this sort of analytical attack of where a transaction has entered the network via IP address. But putting the two together would be Tor and something like Dandelion ++ would be very, very nice. So those are the things that we can try to balance, the like nice performance and resiliency issues of highly connected nodes and privacy.
All right, very good.
Yeah, so I'm wondering, and let me know when we're ready to move on from this topic, because I could keep talking about it.
Oh,
But
go ahead. Yeah.
it also feels like in terms of resilience, it would be nice if each Zebra node was connected to both Zebra nodes and Zcashds, and each Zcashd was connected to both types,
Absolutely.
to prevent sort of like partitioning by the implementation type. How do we want to do anything to achieve that goal, or just try to monitor it and see if it's panning out in practice?
I think Zebra is literally designed to sync. We only sync from ZebraDs and Zcashds right now. There's nothing at that level. If it speaks a Zcash peer-to-peer protocol, we will talk to you and negotiate a connection with you. But in terms of like who has available connections, and therefore who is able to connect to whom, I'm not sure if there's anything. I'm not sure.
But when two nodes connect, do they know what the other node is running? Is that information exchanged?
They know the user agent basically that they advertise.
Okay.
Yeah.
Okay. So there's the possibility of, you know, making a change to, or there's possibility of getting Zebra and or Zcashd to dump out what nodes it's connected to and what user agents they're running, so that we can keep an eye on whether, you know,
Yeah, you could have a node that is basically logging, oh, I am connecting to Zebras a lot more frequently than I'm connecting, or a lot more often than I'm connecting to Zcashds, how frequently, and things like that. You could do a little bit of that, but you would probably want to be careful about having them in different geographic locations because of network visibility, to make sure it's not just where I am in the world, and the kind of internet connections the kind of network connections that I have available to me is biasing my view of the Zcash network. That's something we could do to keep an eye on whether these sort of imbalanced level of connectivity is affecting which nodes are getting connected to by whom.
Right. We've got the what is it? Get peer info. Yeah, get peer info RPC call that provides, I mean, you might need to tweak it a little bit or something, but it provides a good bit of info on the Zcashd side of what we've connected to at the moment for any given node. So cool. All right. Anything else, Nate?
Yes.
Go
so
ahead.
so I never thought about this before, but I do recall like the Zcashd code has a lot of IP-based network tuning, which I think is terrible. So one thing that might interfere with is if there are multiple peers connecting to your node over the same Tor exit, and it feels like that's something we do want to support. Does anyone know if Zcashd can handle that, and does Zebra have plans to handle that? Like basically don't assume one IP is one peer.
If they're different ports, it's
Okay.
fine. But we also expect you to be on like default ports. But yes,
Okay.
you can have same IP address and different ports and it works fine. That's why I'm able to run a bunch of ZebraDs on different ports from one location at home.
Nice.
So at the minimum.
All right. Okay. All right. I pinged Daniel in chat. So we'll ping him one more time.
I'm here, guys.
Oh, there he is.
Yes.
Okay.
How's it going?
Going good. How about you? Doing double duty on the calls, right? So
yeah, there's the DARPA call going on as well. Anyway,
Okay.
I'm with you all. Yeah, these updates are great, by the way. I feel like they're probably underrated by the rest of the community because you get to learn so much about actual Zcash protocol and networking and stuff.
Cool.
Yeah, so regarding ZSA, so first of all, I'll be joining, these time zones call, I guess every month, because that's when it's bi-weekly, so it's monthly.
Yeah.
To give the updates. We're happy to say that we've started the project a couple of weeks ago. We're really kicking things, forward. We're also hiring a few more roles for the project. That's actually going really well as well. I guess zero knowledge has become a bit of a hypey thing now. So it's attractive. And in terms of concrete progress, we are kind of starting to draft already like the two zips. Mostly for the transfer functionality, the issuance functionality. I don't know if you saw, but there's like a pretty good discussion. Mostly between like Matthew Green, Ian Myers, and I kind of jumped in a bit late, but it's happening and the conversation is really good. We had a very similar conversation internally where we were kind of thinking, should the issuance mechanism be really only like a one-step issuance, or should it be like a two-step issuance mechanism where you're kind of imitating more the Ethereum style version of kind of deploying your smart contract and then actually kind of interacting with it to get the tokens in circulation, right? So I think each of them has their pros and cons. Of course, a two-step is definitely more complex to implement, to ensure security. And of course, in terms of consensus rules, you want to try to mess as little as possible with the consensus rules. But it does potentially provide more extensibility in the future and more use cases for that kind of issuance mechanism. So that's kind of where we're going. Something that we thought that would be super elegant to have is sort of in the one-step issuance, potential mechanism is that you want to have an issuance that is kind of a output-only transaction, say even like an orchard transaction that has a dummy spend, right? And with specific verification for it, maybe add some kind of consensus rule or a few constraints in the proof. I don't have exactly what in mind, but then we would also have a burn transaction that would be just a spend only, right, with dummy outputs. That's a very elegant way to make it happen. And except for the fact that we want issuance and burn to be transparent for now, you would essentially have indistinguishability in the pool from actual transfers, right? Yeah, Deirdre, you wanna chip in?
Could you do both of those? The output and the spend, the dummy input and the dummy output with the like publicly known encryption key, so that it would be shielded but auditable because everyone is just using all zeros for the key or whatever. Right. But in that case, it would still be kind of distinguishable from the rest of the pool because you're still able to decrypt it and see it. That's what I meant. But if in the future we want to say, actually this specific kind of issuance can be private or whatever, then that's doable.
I mean that's kind of similar to how we do Coinbase outputs.
Correct. The shielded one, the latest one.
Yeah, shielded Coinbase. They go straight to a regular shielded output, but they're just required to be decrypted with the all zeros OVK.
And do you and what happens with the spend? Oh well, it's sapling, right?
It's sapling and orchard. Both will do the same thing. So so on the spend side, it's just a regular spend. So if you're like the requirement to make it recoverable means that everyone can, no block explorer is bothered to do this yet, but every block explorer can decrypt that output and see the address value memo of that output, but then they cannot see where that goes because we're only requiring the OVK to be set to all zeros. We're not requiring the incoming viewing key to be disclosed or the full viewing key to be disclosed of the recipient. So where those funds get spent is ongoing is private.
Right. All right. That's a good point. So that's kind of for issuance. I mean, there is a lot of discussions, but what we want to do before having an actual draft of any zip is to kind of push out all of these specific issues that can come up in the forum and get a lot of input. Hopefully you all can also comment there. Yes, Strad? Or Steven? Yeah.
Oh, I was going to say, if we've got the channel in the R&D Discord. If that would be that'd be a great place to have the conversations. That way we've kind of got a one-stop shop for development. That was kind of the reason for setting it up too, because in the forum you have posts that are, they're like whatever grant applications or discussion of price speculation, whatever. And then sometimes like development tidbits get a little, kind of mixed in. It's hard to filter.
I just think that this specific level of discussion is still forum worthy because we want to get the input of like non-developers from the community.
Oh, okay. All right. I haven't seen them.
Right.
How far down it went.
Well, I'll be probably publishing it next week.
Okay.
Mid next week and this week or something.
Okay.
But definitely the component of the zip for the transfer will be, we'll post it directly into the R&D of the.
Okay, cool. All right. Eddie, you had a question? Sorry.
Yeah, I want to say I agree that forum is still the right place to include inputs from non-developers and active users. I do have a follow-up question to Dan. Regarding the issuance mechanism, is there a plan for like an open baton, like keeping it minting even after it is minted once? Like, can the maker of a token continue adding?
This is a very good question. I mean, we're thinking that probably it's not gonna. I don't know. We had several conversations. Some conversations we said no, you just pre-mint everything that you think you're ever gonna want. The other one was, well, no, you just allow them to mint as many times as you want of the same asset type. It's a bit early for me to say what's better.
Well, if you're generally talking about, let's just pick something hypothetical and use it as an example. If you're talking about like an issuance mechanism where you can just say like wrap Bitcoin, for example, you wouldn't, and maybe I'm misunderstanding the conversation, but you'd want people to like, not just there's one wrapped Bitcoin in Zcash, right? But people could, today do some, tomorrow do more, and other people could hear about it and then do it further.
So for sure, this is the case, right? You want to do that, but here the question is not whether you can issue more wrapped Bitcoin or not, because first of all, you can the actual asset type does not say wrapped Bitcoin, right? Like the asset type is kind of agnostic to the actual unit of value. That's external. That's going to be off chain.
Right.
So essentially, many issuers with a different asset type will be able to do wrapped Bitcoin, just like there is Tether and USDT and USDT, etc.
I see what you're saying. So, like
for a given issuer, the question is, how do we make sure? And I think this is a critical kind of security question. How do we make sure that all wrapped Bitcoin in circulation that are already shielded are at least transparently verified to be backed by actual Bitcoin?
That's a good question.
Right? Like, because say that we have one-step issuance, and I'm the issuer, of wrapped Bitcoin, and I issue, 2 to the 56, Bitcoins on as a first mint, right? Like. Then what stops me from, and this is transparent, right? But what stops me from actually transferring, and let's say that, only 2 to the, 10 have been actually issued or backed for me to use them in the chain, in Zcash chain. So what stops me from transferring the rest, kind of putting it into these like shielded things? So this is actually one of the main points of the discussion with Matt and Ian. And sort of
where can I find that discussion?
In the at the end, it's a few comments, the last few comments at the end of the original proposal post.
Proposal. Okay.
Yeah. And so this is a great question, right? I mean, because you would have to have some kind of pending mechanism so that you wouldn't be able to share that. Maybe you want some kind of multi-sig. I mean, at the end of the day, in order to force it in the protocol, you would have to have some kind of oracle. if we are able to, but I'm just thinking out loud here, yeah, like maybe like through the use of Frost, we could potentially enable it if we see that there is a signature on the Bitcoin chain, for example, that can be used as a multi-sig of that transaction or something.
Well,
I don't know.
Wouldn't that be handled by the, let's just call it generically the issuer, right? Like it's kind of like, just think about the opposite, like RenZec and RapZec, right? So that they take care of, okay, your ZEC is locked and you're going to get issued RenZec, so here's your RenZec, we've got your ZEC locked. And then the redemption is the opposite, right? Okay, let's burn the RenZec, unlock your ZEC. It'd be a similar mechanism this way, right? So the key is that issuance component, which also brings in a pretty significant attack surface, right? Because that's where, like you saw with the wormhole bridge a couple of weeks ago, people are like, I'll just mint a bunch of this stuff and move it off chain real fast. So that's kind of becomes like, in addition to the protocol itself, which is always heavily audited and scrutinized, that becomes another component to, really have tons of eyes on and audits and things, if I'm understanding correctly. Addy.
Yeah, so especially Ethereum and Solana and all, they have account-based models. So it's a very different way of having smart contracts and issuing tokens, right? So we have a UTXO-based model. It's a bit different. Question to Daniel, is there a policy ID thing? Like for every time an issuer mints, will there be a policy ID created so the issuer knows how many mints have happened in this policy and those policies, and then take care of the total issuance?
So look, the answer to this, I mean, again, we're still not at that level, but the answer I can give you is we at QEDIT, our first product like a few years ago, we did some similar extension to Sapling back then. And we didn't implement a two-step issuance. One where there was like we called it like a rule. So there was like because it was a federated system for enterprise and stuff, there was like a system for an admin to say this address is allowed to issue this type of asset. And that is the policy in a way, right? And then there would be the actual issuance, which was shielded and so on. But I don't know if it's worth having, that extra complexity at the consensus layer to have these policies. But on the other hand, I don't know how we would do it without how to accomplish certain use cases without it. So definitely the part of the trade-off to consider.
Dodger?
Feels like and maybe this is like, maybe this doesn't avoid the complexity at the protocol layer, but it feels like maybe the simplest policy you could have is just a limit on the number of tokens that could ever be minted, that could ever be issued. And to have an option, if the limit is set to 0, then it's unlimited, which would cover the use case of a stablecoin issuer, for example, who doesn't know how many dollars they're going to want to issue, or pounds or euros or whatever it is.
Yeah, like that seems to me to be the main limitation of having you must define your full set up front mechanism, because if you need to go over that limit, well, if you need to go over that limit, then you're forced to pick a new ID, and then it becomes non-fungible with the previous assets, which is the same problem we have with wrapped Bitcoin from different providers. They're non-fungible with each other. So it's a problem that we will already have in the ecosystem if different people are wrapping, and that's, I think, what we discussed in an earlier one about like maybe being able to have like delegation of who is issuing under a particular issuer's asset ID. But I suspect the general case of flexibility is going to be, I agree with Daniel, it's going to be tricky. But I don't think it's something we should prevent in the design. Like maybe like not implementing it to begin with is one thing, but like if it's not possible to implement or not possible to migrate to such an implementation later, I think that would be a mistake in terms of cutting off, restricting ourselves to finite issuance interactions.
Yeah, no, definitely agree with that.
I just lost some audio packets there.
Can you hear me now?
Can now.
Yes.
Yeah, I think.
All right. 1 second. Yeah. So what I was saying is that like your point also makes me really like think about the importance of how extensible these features are, right? Because we don't want to think just that the short term of just a new 6 or whatever. We want to make sure that whatever we build forward, and especially now that I think ZSAs, and I hope that ZSAs will also open up the stage for other developer teams to want to chip in terms of applications, that they won't have to rethink about what the protocol looks like if they want to, add specific features to say like the issuance mechanism, right?
Right. Yep.
That would be ideal in my opinion. All right. So I do have a couple of kind of questions that I think is worth discussing in this forum. Okay. Let's start with the first one and then go to the second one. Like, how do we imagine doing like migrations between, let's say, Orchard and Orchard ZSA or whatever? Because
I have an opinion about this.
The reason I asked, so let me just explain the context here of the question. So it says is that like we don't plan on having support of unshielded custom assets.
Right.
And turnstiles so far have kind of been depending on unshielding of the ZEC. And so we need to think about how, like I guess the ZEC could still be done in that way. Maybe we can, yeah, okay, so that was the context. But yeah, Dara, please.
Strad, your hand.
Okay. So first of all, Orchard plus ZSA is not a different shielded protocol in terms of using different commitments or nullifiers or the way that
should be the same anonymity
constructed and tied together. So it is entirely possible to make it compatible in such a way that no turnstile is needed. That doesn't answer the long-term question about if we did have some incompatible change to the protocol, what we would do. But just for Orchard itself, I don't personally see any strong motivation for a turnstile between Orchard and Orchard plus CSAs. And I know that Zuko disagrees with my reasoning on that.
So let's just get a little bit more in detail here. Like, how would the transmission, the migration happen? Like, if I have an Orchard ZEC, I want to use it as a, I don't know, fee in a ZSA transfer. Right? I can just put the same action into a ZSA transaction or transfer. Like that would be the ideal scenario, right? Like that we could just reuse the same action.
I was assuming, I don't know whether other people are assuming the same thing, that we would just replace the existing Orchard action circuit with for let's say V6 transactions with another circuit that supports ZSAs but is otherwise compatible.
Yeah.
That
was
so
kind of what I had in mind as well.
So what you're saying is essentially that the same node structure and nullifiers for my Orchard ZEC can be input directly into the Orchard ZSA proof.
Yes.
And then sort of it's more of like an off-chain migration. Like the wallet would do it essentially. Like that'll be a thing of the
I mean,
wallet.
there's basically nothing to migrate because it's all the same pool.
Yeah.
Well, no, but I mean, you know, from the user perspective, there needs to be something that tells them, I need to take this node from this kind of, you know, a orchard state to this other orchard state, right? Like the wallet needs to be able to do so.
Why does it need to be visible to the user?
Not to the user specifically, but like the wallet itself needs to be able to do it, because if not, the default is just to generate the orchard proof, right, for an orchard node.
Oh, so okay, so
like some function needs to happen at the API level. That's what I'm thinking.
Assume, for example, that NU6 adds a V6 transaction that supports CSAs. You can still send V5 transactions that use the old proofs, or you can send V6 that use the new proofs. Because they're operating on the same note commitment tree and the same nullifier set, it's basically just an implementation choice whether you use a V5 or a V6 transaction, except that you have to use V6 when you have assets other than SAT.
So I want to hear from Strad. His hand went up really early when you brought this up, so I think you may.
Yeah, let's see if I can remember what I was thinking. Okay, yeah, you mentioned we're not going to have transparent assets.
Custom assets.
Yeah, custom assets. Yeah, I agree there. There still needs to be a way to see, like, to shield and unshield that value during issuance. Ergo, there has to be a mechanism equivalent to the value balance field for ZEC to bring funds into and out of a pool. Therefore, I would say that the confusion here is basically one we actually had yesterday in another meeting, which is that the transparent pool means two different things. It means the pool of funds that are sitting in legacy Bitcoin style transparent committed addresses, and it means any funds that are not in a shielded pool. And the latter is what's relevant for the turnstile going through a transaction. Because you take, when you're moving funds from, say, Orchard to, future pool, or say sapling to Orchard, put it that way. Your funds are at rest in a sapling address. They then, in the transaction, are removed from the sapling pool into the local intra-transaction transparent pool, and then immediately move into the Orchard pool without ever landing in a transparent address.
In one
the same
transaction.
thing can be done for migration from a V1 ZSAs to V2 ZSAs, if that's having to cross a pool, where you just effectively it becomes I am spending from my V1 ZSA address to a V2 ZSA output that happens to be in the second pool. And you can do that. The amount has to get revealed if you're transferring, going past the turnstile, but you never have to have support for storing them transparently.
So
this answers my question, because we were thinking that you may not need to have that V balance transparent output for the shielded assets, but then now that you say this, for extensibility, at least, or for future versions, you may want to. The question is, how do you do it without giving away sort of the actual assets?
Okay, so
you can't have one single V balance that is for all assets.
Correct. In the earlier discussions that we'd had both internally at ECC and around, and I think with you earlier, the thinking had been that in addition to always having a value balance present for ZEC, because ZEC's pretty much always going to be involved, you would have like a list of other value balances tied to certain the bases that are used, which, given the proposal that that Darren and I had for the the way to do them efficiently in Orchard, where you had fixed spaces, you need to define which assets are used for which fixed spaces in the circuit anyway. And so as a result, that mapping, you have to store that mapping in the transaction somewhere, so that a commitment to that ordering has to be stored in the transaction. And so that commitment could, instead of being a commitment to the ordering, could just be that value balance ordering directly. And if you're having to publicly reveal, like, here's the asset ID and the balance, then a verifier can just derive the commitment to that ordering based on the ordering in the transaction, and then use that to validate proofs. So you have to store that ordering somewhere, and then it would be a little bit more data on the transaction, but it gives you that value balance functionality. Whereas without that, you can only balance within a transaction. So you then have to, like you said, figure out the issuance piece. And I have not kept up on the thread, so I'm not familiar at the moment with what you were thinking in terms of private issuance here. But the issuance can't be entirely private. It has to come from some identifiable value. And if that can be done in a way where it just also leverages the value balance field, then you get that extra flexibility in terms of how you pass things around. But yeah.
All right.
I'm going to clear the queue of hands. So we've got quite a few up. Nate, you're next.
Okay, I'm here to talk about turnstiles and their purpose. So I think there's some confusion because different people see two different purposes for turnstiles. So one is there's this data structure, and we have this new version of the data structure, and so we have to do this maintenance so that we can upgrade to this new thing. So it's like a maintenance burden for technical maintenance. The other purpose of a turnstile is to audit the supply of the asset. So when you think about why do we want issuance or redemption of a custom asset to be transparent, it's precisely so that you can make proofs that the supply has the proper reserves for that issuer, right? Like the amount of zBTC matches the amount of locked BTC. That's crucial for that kind of asset usage. So there's a similar rationale for why to have turnstiles, and that is to audit the supply sort of in place along some schedule.
Okay, can I just interrupt for a second?
No.
Okay,
please wait for me to finish, because I know what you're going to say, but please wait. So there are two different reasons to have a turnstile, and both of them are important. One might be if we need to change the commitment tree structure in some way. And I want to point out, even if we all decide let's never audit supplies anymore, what a great idea. Even if we decided that, it is still very possible in my mind that we want to be able to change the commitment data structure in the future, and therefore we will want to have a migration, and therefore we should definitely anticipate that for the ZSA feature. So whether or not we can sort of transparently introduce ZSAs without a migration, I consider that kind of a separate question. I would still want to have some sort of migration plan, even if we decide to do like the transparent sort of introduction. By transparent, I mean like, backwards compatible with no migration needed. Okay, that was my spiel.
Thanks, Nate.
Going down the queue, Deirdre.
Yes, I threw some comments in the chat, but also no, never mind. It's fine. It's just that'll be the side queue. Just to confirm kind of what we were talking about, everything being in the Orchard shielded pool ZSA or regular ZEC note means that our note commitment tree may be Orchard note commitment tree may be a commitment tree of ZEC notes and ZSA notes of various types. Will they all be notes for different things, or are they no longer all notes anymore?
Each note is for In the proposal that Strad and I came up with, each note is for a single asset.
Asset. Okay, so they are notes for different kinds of assets, no longer ZEC notes.
Yeah,
which
it would
they
be
have.
one shared tree with all notes for all asset types.
Cool.
Yes.
That was it. Cool. Thank you.
Cool. And Dodger.
And yeah, so as
sorry.
assuming Daniel and the rest of QEDIT aren't proposing altering that semantics, I should say.
Yeah.
Right.
Yeah. Purely semantic sort of. What are we all
We're
talking
not.
about when
We're
we
not.
say notes?
Yeah. We're not thinking about changing that, or at least not our proposal won't do that.
Cool.
All right. Dodger.
So yeah, so I just wanted to go back to something that Strad said quite early on in what he was saying. It's one of the problems of having a big long queue of people is we're rewinding like 20 minutes to talk about something. Strad, you talked about transparent issuance of assets, and I think the way that you talked about it, you seem to be assuming that the issuance would use a transparent address or would use the transparent protocol or subprotocol of Zcash. Okay.
I am not proposing that it use the Bitcoin script stuff. I would very much like us not, to have little dependence on that as possible. What I meant is that whatever mechanism handles the logic for here is the issuance, my assumption there was that it would be desirable for that to be transparent.
So let me just jump in here and quickly before you go off on another 20-minute spiel. So I think maybe something that got missed out is one of the ideas that's been knocking around is that in the same way that mining directly to a shielded address requires that the OVK is all zeros or something, which means that you can, so then, and let's use a different word for this. Let's use visible instead of transparent so that we avoid confusion. It means that issuance of coins is visible. And one of the possibilities is that issuance of shielded assets is done in the same manner, and that gets enforced at
I have no problem with that. Yeah. And I was not making any assertion that we couldn't do that. My point was that the Orchard protocol as is, and even the Orchard protocol with a presumed extension to allow transacting and transferring assets around, probably is insufficient to be able to do issuance. And the circuit changes required to do private issuance in that way, even made visibly, would probably not be reasonable to require every single user to do as part of the same proofs for the same anonymity set. I suspect that people who are doing issuance will need to make those transactions distinguishable from people who are just doing regular transactions. And as such, the protocol used to implement that issuance mechanism, whether it be another circuit, whether it be just simple accounting by nodes in whatever, that mechanism would essentially be a separate protocol, and then you have the question, okay, well, how do you then get funds from that into it? My guess would be, if you wanted to be able to privately get funds from the issuance mechanism into the Orchard pool, then essentially the issuance mechanism would need to be able to be essentially issuance mechanism plus Orchard transactions, which then seems like it's adding extra complexity to that. So I don't know. The simple thing to me, the simple approach that I saw was we have one protocol for doing issuance, and that can be shielded or transparent, whatever. We have a protocol for transferring things, and then when you actually issue something, it goes through the turnstile part, and the amount gets revealed at that point, and so we can keep track of how much of each asset is going into each shielded pool, and then that's like it. Shrug emoji.
Yeah, that was the second thing that I wanted to highlight, was that I would struggle to, obviously I'm not a cryptographer, but I think I would struggle to see how, or my instinct is that it would be impossible, if not very difficult, to allow for shielded assets to move from one shielded pool to another without revealing the type of shielded asset and the quantity. And even if that were possible, I'd question whether it was desirable, because as has been pointed out, it would potentially undermine the auditability aspect of the turnstile. And then finally, I think another useful potential future usage of the turnstile approach is if we were to ever end up migrating off the current Zcash blockchain onto a new blockchain as a means of effectively abandoning a whole load of tech debt and moving on to a Zcash next gen, and having the turnstile approach. And here, I'm afraid, Dara, I'm gonna agree slightly with Zuko in a way that I think it's useful to have people almost used to turnstiles, so that they understand what's going on when you move from one shielded pool to another, and then in the future when you move from one blockchain to another. I see that Dara's got 6-7 fingers up now.
All right. So Dara's up. Just before you start, I've got a hard stop at 9:28 because I've got another call, or at 28 after. So you've got at least 6 fingers up, I can tell, maybe 7. So take it away. But we can't hear you because you're muted.
And you have no hands to unmute.
You can't unmute.
Okay. The first 2 got answered, I think. The third, there is. So Nate gave 2 reasons to have turnstiles. One was for auditing, and one was for transferring between pools using different tech. So there's both the transferring between different pools when there's a technical necessity to do so, and there's doing so for security reasons, because either there's of a flaw in the previous pool, which was the case for Sprout before sapling, or you want to remove some attack service from the protocol. So in the long term, you absolutely do need to be able to migrate between pools. And one of my other points, I think, was that yes, that means you absolutely do need to be able to reveal amounts of assets other than ZEC in the internal transparent value pool for a transaction. So there are these 3 reasons for doing turnstiles, but you don't necessarily need to do a turnstile in order to change the tech, because what you could do is prove in the new proving system that you would prove something about the old commitment scheme, the old Merkle tree, nullify assets, and so on. So that's increasingly possible now that we have lookups in our proving system, because even if you want to do a proof about some different curve or some heavyweight hash function, for example, it's still kind of feasible to do it, not necessarily indistinguishably though. I think I've done about 4 of my 7 points. No, 5. The others were there was one more. It was that there are other ways of assuring supply integrity that don't necessarily reveal amounts. So there's kind of an analogy between private election protocols and this problem of having auditable transfers between pools, because in an election protocol, you don't want the ballot of a particular voter to reveal information. You kind of have the same problem with a transaction that's hopping a turnstile. So there's a way to, there's a potential solution to this that works for both election protocols and for the private pool hopping problem, where you can have a set of auditors that can't, that are doing a multi-party computation, and you can have unconditional supply integrity across the turnstile, but the privacy of amounts is only violated if all of the auditors cooperate. Okay, I think that's everything I want to say.
All right. Very good.
But as far as the design of the protocol is concerned for ZSAs, you do have to be able to reveal amounts in all assets. So not disputing
that. Deirdre.
A little bit of surfacing from the chat.
Okay.
So thoughts are possibly, instead of one proof for transfers that's currently designed into Orchard, we'll have the transfer proof and an issuance proof, which would allow shielded issuance of new asset types, right? Not every time you want to get a new instance of an asset, because you don't need that. If the asset exists, you can just swap Zec for new asset type in a transfer proof.
Are you thinking in the context of if all of the asset is issued, quote unquote, up front?
Yeah.
Yeah, like in this two-step issuance.
Yes.
But you said swapping. Here swapping is tricky. Usually, if you think about swapping, you would need some kind of like two signatures, so it's a bit of interactive and stuff like that. I mean, it can be done with the current structure, which is amazing, but in the issuance context, swapping may not necessarily be interactive as long as there is also like a transparent component, and then the validation can be done by the consensus. Mm-hmm. In the sense that one action is kind of requesting funds from that issued or registered pool of funds, and in exchange giving some ZEC. The problem there is the value, right? I mean, that's an off-chain thing. So
that's basically why I don't really see.
Well, but this can be like NFTs, right? It's a good case for NFTs, because NFTs you have this pre-mint price, right? You say, and it's like the base currency or something. So like, you know, anybody want to create like some NFTs, although NFTs is not a great use case because everybody wants to flex them, and they need
at that point it sounds like what that is not actually an issuance mechanism, but a Dropbox DEX kind of thing. So like it sounds like Backpage for assets. Like I could
at the end of the day,
I post up a listing here, you pay me this amount and you get it, which is not quite the same as an issuance.
It's not. But it is one of the use cases for issuance.
Yes.
Yeah.
So it's a possibility to consider, and having that two-step process is definitely easier to achieve that. So okay, that's another. Cool.
Yeah. There was another note in the chat about splitting up the circuits, and the Orchard circuit could definitely be split into two in that way, in the same way that Sapling was. The only thing the particular thing you'd have to be careful of is the uniqueness argument. So we were pretty careful with Orchard. We needed to ensure that nullifiers are unique, and when they're generated, they will become unique. Mm-hmm. And so for the way that we do that is by having, we fold in via this row value. This row value is required to be unique, and when it's in the single action, we just pull that row from the nullifier that's being revealed of the previous output, which is public and enforceable consensus to be unique, and so that we get this uniqueness chaining. If we split that up and we instead have an issuance mechanism that has the ability to create orchard outputs that get added to the tree, then we'll need some other mechanism to sort of seed that.
But it's not needed, because when the point of splitting is because you're in the edge of the chain.
Well,
so you're
that's
either
exactly
creating
my
it or
point.
burning
Well,
it, so you don't need to come
in the orchard circuit. We seed that for when you're shielding and you're creating a new orchard output with no orchard input. Well, you still have an orchard dummy output, and that has a dummy nullifier, which consensus forces to be unique.
I see. Got it.
Yeah.
Got it.
So you would need some other way to enforce uniqueness for within the issuance mechanism, which might fall out of the protocol.
I mean, it's straightforward, because just make up a random nullifier. With overwhelming probability, it won't. If it's chosen randomly, it won't collide with any other nullifier.
Yeah, it becomes a little trickier to argue that it is. Will be unique, because you could, if it is just random internally, then the issuer could pick, whoever's doing the issuance could pick one that will intentionally collide potentially.
Does that also put more pressure on a local RNG to be secure and fully random than if it's chain all the way back?
So the way it works for dummies is that the creator of a transaction can't just choose any arbitrary nullifier. That it has to be the output of a PRF. So let's see.
No, we don't even rely on that. Even assuming assuming that was not the case, and the dummy that you're choosing had a completely adversarially controlled nullifier, the transaction still has to be submitted to the network and has to be acceptable against that. So the failure case here is if the local user has an RNG that is broken in some way that causes it to generate a dummy nullifier that happens to collide, the transaction gets rejected by the network, the transaction fails, the user just has to try again. You don't end up in a situation where you have successfully mined a transaction where the newly created output node will have a colliding nullifier. That relies on the way in which we chain the nullifiers through the usage of the specific nullifier computation that involves Poseidon and DH and things to and ensures that we fold in the uniqueness of that.
So there is quite a subtle security property that Sapling and Orchard have, which is that you can't do a roadblock attack, which is where you see someone else's transaction and then can create another transaction with a colliding nullifier. And the reason you can't do that is that the input to the nullifier computation sort of requires private inputs to the ZK proof.
That aren't visible on chain.
Yeah, if you are not the holder of that note, then you wouldn't know those.
Yeah, even in a scenario where we had like the OVK is visible and you can see the output data, that's still insufficient because you don't see any of the spender data.
Exactly, yes. Yeah, you need to know the spending key as well.
Nate, I noticed your hand went up and down a time or two. I don't know if you had a comment or a question that was answered.
It was a question, but I think I'll save it.
Okay, cool. All right. Well, great conversation, and I'm sure we could continue on for an indefinite period of time, but we do need to wrap the call up. So,
sure.
But yeah, these we have, again, just for everyone that might be watching after the call, we have an Arborist call at this time zone every other week or every other meeting, which is once every 4 weeks, and then in kind of the traditional slot, if you will, the alternating time. So yeah, look forward to continue the conversation on the next Arborist call, and then also async in the forums and R&D Discord. So all right, everyone, have a good rest of the day. and we'll talk to you later.
Thanks, everyone.
Thank you.
Steven. Thanks, everyone.
Bye.
Thank you.
Bye.
Bye.